Okay, so today we're going to basically go over like two VSL-related studies. The first one is this study that is about what happened when they raised the speed limits on interstate highways. And the second study is one that I sort of mentioned very briefly at the last set of slides. There's like this cancer cluster in Nevada, and the author, who's actually here at Berkeley, wants to estimate how housing prices react to that cancer cluster to get a sense of how people sort of value the risk that's involved there. Before we get there, though, I just wanted to finish up talking about sort of that literature survey, the overview of literature on the VSL. So the third category of studies that is summarized there are these international labor market studies. So these are basically just the same as the U.S. labor market studies we talk about, except now it's a different context of the different countries. So the design of these studies is to run regressions of wages on job or worker characteristics and job risk, and then the coefficient on job risk is the coefficient of interest. You want to see how wages differ depending on job risk, and ideally you would think that for a riskier job, all things being equal, you have to pay people a higher wage. A quick summary is basically that the VSL estimates in other developed countries, so Europe or maybe like Japan, appear roughly similar to VSL estimates in the U.S., and then as you would probably expect, the VSL estimates in developing economies appear significantly lower than the VSL estimates in the U.S. So to just kind of put a number on what they're finding, they basically summarize the evidence. So they summarize the evidence on the value of physical injury, and then they look at, so that's sort of the injury equivalent of VSL. That's, I think in general, like harder to estimate than the value of physical life, and the problem is that there's a lot of heterogeneity in injuries, right? So basically, a life is a life regardless. It's pretty easy to code those up, when somebody died. But when you're talking about an injury, there's a lot of different types of injuries that somebody could potentially suffer, and presumably, depending on the type of injury, they might attach a lower or higher value to avoiding that type of injury. So it's not clear how you would sort of consistently code up injuries if you were trying to estimate the value of physical injury. It's also the case that if you apply sort of the same methodologies that we've been discussing to estimate the value of physical injury, usually the number you get is going to be hard to distinguish from the sort of simultaneous effects on the potential for dying. Because if you think about, say, some sort of risky job that's more likely to injure you than an office job, that type of job is also going to be more likely to kill you almost surely. And so if you see that there's a wage premium for that type of job, you don't know how much of that wage premium is being paid to compensate people for the risk of death versus how much is being paid to compensate people for the risk of injury. So a lot of times, sort of the injuries and deaths are kind of sort of conflated into one bundle. Nevertheless, there are some attempts to try to sort of estimate how much people are willing to pay to avoid specific types of injuries, and so those estimates are summarized in that article. Then also the income elasticity of the VSL is summarized. I think it's about 0.5. So the way you interpret that, essentially, when income doubles, then the value of physical life would increase by like 50%. So they're not finding like a one-for-one relationship, but they are certainly finding a positive relationship between income and the VSL, which is again I think what you would generally expect. Basically, as people become wealthier, they can afford to sort of make greater investments in safety to protect their own lives. Okay, so we discussed like some of the specific issues with the different types of studies, so like the labor market studies versus the revealed preferences studies when you look at people buying safety-related items. But there's a couple of generic issues that affect basically any type of VSL study that you can come up with. So the first one is whether or not the individuals actually know the risks that are involved. The risks involved are generally small, and it might not be easy to sort of find evidence. So if you were like you want to be an informed consumer, and so say you're buying a car and you want to sort of figure out like, well, how much should I invest in various safety features? It's not going to be clear to you exactly what the effect of those features is on reducing the probability of dying in a car accident, right? You might not even know, first of all, what the probability of dying in a car accident is, and even if you did, you still don't know exactly what the effect of, say, a better airbag is or something on that probability, right? So even if you are sort of making the effort to figure out what the safety benefits are for a given feature, or say the risks for a given job are, it might not be easy to find that information. And in some cases, those numbers might not even be known until some researcher goes and estimates them. And then sometimes even if the researcher estimates them, you might not believe the estimate because of some sort of mid-variable bias problem. So whether or not individuals are fully informed about that risk, I think is a big question in a lot of VSL studies. And if individuals aren't fully informed, then it's kind of hard to interpret their willingness to pay as being a willingness to pay to avoid some particular level of risk because you don't know sort of what level of risk they're envisioning when they make that payment. The second thing is that even if you know what the probabilities involved are, it's not clear that individuals always understand very small changes in probability. So there's evidence in behavioral economics, which is kind of like a branch of economics that studies how individuals actually behave as opposed to sort of neoclassical economics, where we assume that they're perfectly rational, perfectly informed, and so forth. And so in sort of field experiments in behavioral economics, the evidence suggests that individuals tend to overweight small probabilities. So they may not. So on the one hand, it's like sometimes there are sort of very rare events that people become focused on. So thinking about like plane crashes or something. Like a lot of people have a fear of flying, even though on a per mile basis it's at least like a couple of orders of magnitude safer than driving. So on the one hand, people seem to overweight small probabilities. On the other hand, if I tell you like I'm going to decrease the chance of you dying in say a car or something by like from 0.0001 to quadruple 0.09, which I think is like a 1 in 100,000 reduction or something. It's very hard to sort of distinguish between those two numbers because they're so small. So people might sort of ignore them. I guess if you were sort of a true libertarian and you just kind of said that we should just take people's preferences as given and just basically assume that whatever they choose for themselves is optimal, then maybe this doesn't matter to you. So even if they're kind of making misinformed choices, you're saying, well, it's their choice to make misinformed choices. So maybe depending on sort of what your views are, you might not care that individuals may not understand small changes in probability, but certainly when interpreting the VSL as we do, is basically marginal willingness to pay for some very small change in the reduction of a fatality. It's basically necessary to assume that people do actually understand small changes in probability and that they're informed about the risks involved. So it's actually, I should say, it's not technically they don't need to be informed about the risks involved. Like, so if you think that say an airbag is going to reduce your probability of death by let's say 1 in 1,000, and it's actually going to reduce your probability of death by say 1 in 10,000, so you're assuming that it has a bigger effect than it actually does. Then what we're going to observe is that you're going to sort of overpay for that car bag relative to if you knew what the true risk was. That being said, if we were just interested in estimating your value of physical life, as long as we knew what your perception in the change in risk was, it wouldn't matter what the true change in risk is, right? Like, so what we're trying to elicit from you is how much you would be willing to pay for a given risk reduction. And so if we knew exactly sort of what in your mind the risk reduction was when you were shelling out the money, then that would be sufficient to estimate the VSL, right? So like in some sense, purely from the perspective of estimating the VSL, we don't actually care that your perceptions are incorrect as long as we know what your perceptions are. The problem is that we almost never know what your perceptions are, right? Like, so we're just working with a data set that's being collected. We would never know what your perceptions are because all we know is that you bought this. I didn't know he's going to ask you when you buy the airbag, oh, how much you think this is going to reduce your chance of fatality by, right? So since we don't actually know what your perceptions are, then we have to basically assume that your perceptions are correct. So we have to like go into the data, see how much the airbag actually reduces the fatality risk by, and then assume like, well, you also knew that, and therefore we'll assume that your perception was in fact the correct amount, or that you correctly perceived the risk reduction, and essentially impute then that you thought that it was going to reduce your fatality risk by whatever the correct amount was. So in practice, like we need to assume, in practice, like we only know what the true change in the probability is, or at least our estimate of that true change, and so we have to assume that you had the same estimate. If we could somehow get inside your head though and like figure out exactly what what you believed, then it wouldn't even be necessary to know what the truth is. We only care sort of what you believe. So the reason I'm saying that is that I think probably on some of the problems, certainly on like some of the past exams, you'll see questions where I'm asking about whether some sort of like error in an individual's thinking or some sort of bias in the study could potentially affect your estimate of the VSL, and if it does, whether it's going to make the estimate too large or too small. And when you're evaluating that, it's critical to sort of understand that what we would like to know is what the person who's shelling out the money thinks the change in the probability is, not necessarily what the true change in the probability is. Okay, so the first study that I want to talk about in detail here with that tries to estimate the VSL is this Ashenfelter and Greenstone study. So I say like it is one of the more compelling VSL estimates. I think there's sort of two components to it. So the first component is that they're trying to estimate the risks of changing the speed limit on fatalities, and so I think that part is pretty compelling. Then the second part is they use those changes in risks and compare them to the benefits of increasing the speed limit. So the benefits are going to be reduced travel time, and so then they can put a monetary value on those benefits and come up with an estimate of the VSL, because you're basically sort of saying, okay, here's some additional risk, but then you get some additional benefits, and if we compare these two figures, we can sort of figure out what the VSL is, at least in like the policymakers' minds, because it's the legislators that are choosing to increase the speed limit. That part is a little bit less. To me, it's a little bit less compelling that they end up with a great estimate of the VSL, but we'll talk about why that is a little bit later. Okay, so the background here is that back a long time ago, like before most of you were born, I believe, the speed limit was only 55 miles an hour on all highways in the United States. That itself was actually a reaction to, like, it used to be higher, and then there was an energy crisis, and so they reduced the speed limit. We'll get to that. But when it was 55, they decided in 1987 that they would permit states to raise the speed limit on rural but not urban interstates up to 65 miles an hour. And so the idea underlying the study is that some of the states choose to raise the speed limit, others don't. So it was basically a federal policy that said, everybody has to have 55 mile an hour speed limit at the beginning. Then in 1987, they give you the option to go up to 65. That doesn't mean you have to go up to 65 on these highways. It just means you can do so if you choose to. But the idea is that among the states that do choose to go to 65 miles an hour, then presumably they're going to value the time savings that accrue from having a higher speed limit at an amount that's greater than the lives lost from the higher speed limit. Otherwise, it wouldn't make sense to raise the speed limit, right? So it's basically a reveal preferences idea. So if that's true, then we can estimate the maximum willingness to pay to save assisted life in those states. Just to give you a very quick summary of the results before we get into the details here. So it turns out raising the speed limit to 65 miles an hour from 55 increases speed by about 4%. So you might think, wait a minute, that seems kind of low because you're going up by like 10 miles an hour, and that only corresponds to 2.5 miles an hour. But of course, many people were exceeding 55 even when the speed limit was that. So just because you raise it to 65 doesn't mean everybody's going to uniformly increase their speed by 10 miles an hour. It just means probably less people will be speeding. Fatalities increased by 36%, so that might actually surprise you. Seems like a pretty large number given that speeds only go up by 4%. And then valuing the time valuing people's time at their hourly wage ends up implying a VSL of about $1 to $1.5 million. So if you remember, I said that the sort of probably typical study in the summarized in the Viscusi and Aldi paper says or gives a VSL of several $1 million. So this is actually a little bit on the low side for a VSL, and so I'll talk about my thoughts on that a little bit towards the end. So the issue here, of course, is once again they're going to show that speeds and traffic fatalities are correlated, but correlation doesn't imply causation. So we're generally concerned about confounding, also referred to as like your selection bias or your variables bias. And so in particular in this case, they need to estimate the effect of the speed limit on fatalities in order to get that sort of first part of the equation. If we raise the speed limit, how much does that increase fatalities? How much additional risk are we taking on here? But the states that have higher speed limits might have higher fatality rates for other reasons as well. So I'll show you a map in just a moment that shows you sort of the distribution of states that choose higher speed limits versus states that stay at 55 miles an hour, and you'll see that it looks essentially like very non-random. So the states that choose higher speed limits tend to be more rural. That means they're going to have fewer hospitals per square mile. They're going to have more undivided highways, which are basically the most dangerous highways you could drive on. Just for your own information, like divided highways, like what you find here in the Bay Area and all the urban areas, are actually pretty safe. The reason is because there's almost no chance that you'll hit another vehicle head-on since the traffic in the two directions are divided. Driving around like the roads in Berkeley or something, also relatively safe, at least if you're in a car, not a pedestrian, just because the speeds involved in a collision are not going to be that high in general. What's unsafe is if you're going out to a more rural area where they have two-lane highways where the speed limit might be like 50, 60, even 65 or 70 miles an hour on some of these small roads, and there's no divider, so then you have the potential for like a combined collision speed of over 100 miles an hour. Unsurprisingly, that's very dangerous. So these rural states have higher speed limits, but they also just have fundamentally more dangerous highways. They also have higher alcohol consumption, obviously not good for traffic fatalities. Lower seatbelt usage, also not good. So there's all these reasons why you might think that states that have higher speed limits might have higher fatality rates even absent those higher speed limits, right? So the raw relationship, if you just sort of like compare fatality rates in high speed limit states versus low speed limit states, that raw relationship is probably going to be contaminated by some sort of convention. So ideally, what we'd like to do is randomly assign the treatment across states. We talked about how a randomized control trial is the gold standard of evidence, and that's why the FDA, for example, uses it with drug trials. But that's not going to be feasible here. You're not going to, like, the government is never going to allow you to come in and like randomly assign speed limits across the 50 states. So instead, we have to look for what we refer to as natural experiments that are going to induce some sort of quasi-random variation in the policy of interest. And so the authors in this study argue that 1987 speed limit policy is a natural experiment, that when the federal government lifts the cap on speed limits from 55 to 65 miles an hour, raises the cap from 55 to 65 miles an hour, that's going to basically induce the sudden change in speed limits in some of the states that's not likely, at least they argue, to be correlated with any specific change in other attributes, other factors that might affect fatality rates. So this basically allows them to implement the differences in differences design that we've discussed before. And so what they're going to do is sort of treat the 65 mile an hour states, or the states that adopt 65 mile an hour limit as the treated states, and then use the ones that don't adopt that 65 mile an hour limit as the control states. And then they'll just compare the changes in fatalities in treated states versus the changes in fatalities in the control states. So if we just let YST be the fatality rate in a given state in a given year, then the difference in differences estimator is going to be this difference in basically fatality rates in treated states, which is that first difference, minus the fatality rates, the change in fatality rates in treated states, which is the first difference, minus the change in fatality rates in the control states, which is the second difference. So again, as we discussed earlier, this is going to really eliminate two types of biases that we would be concerned about. So the first thing it's going to do is eliminate cross-state differences that are constant over time. So for example, I said that the control states or the treated states, the ones that adopt higher speed limits, are more rural, and the control states are more urban. So to the extent that sort of the urban versus rural mixture in a state is not changing much over time, it does change obviously, but it changes relatively slowly. So to the extent that that's constant over time, then when we eliminate constant over time within a state, then when we eliminate these cross-state differences, that's one of the potential confounders that's going to be eliminated by the disincentive design. Okay. The other type of confounder that gets eliminated is essentially changes over time that are constant across states. So if there's something that's just sort of trending in general in the United States that's reducing the fatality, the motor vehicle fatality rate, which is certainly the case that has declined at least on a sort of per mile basis over time, to the extent that those factors are all trending equally in all of the states, then those factors are also going to be swept out. And in particular, that's kind of like why you have this, you're using the change in fatalities in the control state as your counterfactual for what would have happened in those treated states to fatalities had they not passed had they not lifted their speed limits or increased their speed limits. So the overriding concern here is going to be whether or not the treated control states would have evolved similarly in the absence of the speed limit intervention. And so in particular, we need to think about whether there are other factors that could be changing differentially in the treated states versus the control states. So for example, if it turned out that alcohol drinking rates were falling faster in states that don't raise speed limits than in states that do, that would create a bias in our estimates, right? So basically, what that would do, so if they were falling faster in the states that don't raise the speed limits, then what you would see is that the control states here would essentially see a greater improvement, like a greater reduction in traffic fatality rates than the treated states, and you would sort of impute that, oh, okay, I think that, so let's suppose that the fatality rate in treated states was just flat during your sample, right? Like it didn't change. Initially, you might think that the policy had no impact, but then if you looked at the control states and saw that fatality rates were actually declining in those states, you would say like, oh, then I think this policy did have an impact because I would have expected the treated states fatality rates to decline over this period had there not been a policy. They didn't decline, therefore the policy had a positive increased fatality rate. And that would be correct as long as there weren't any factors changing in the control states behind the scenes that as long as there were not any factors changing in control states behind the scenes that weren't evolving similarly in the treated states. So if there were this reduction in drinking rates in the control states that wasn't mirrored in the treated states, then that would be the explanation for why you observed this reduction in drinking rates in traffic fatalities in the control states. And if you then assume that you would have seen that same reduction in the treated states, which is what disincentive does, you're going to make a bias difference there. However, if the difference in drinking rates across the states was either constant, so it wasn't changing over time, then that wouldn't be a problem because it would be a factor that's fixed over time. Or if if we're just looking at sort of dropping the overall drinking rate, so if the drinking rates were declining in the control states by the same amount as they were in the treated states, then that also wouldn't be a factor. Also, I mean, the thing with drinking rates is that's something that you might actually be able to also measure in the data. So if you could include it as a control variable, then that specific factor would not end up causing a bias in your estimates. But in a lot of cases, you'll come up with a factor that theoretically could be a problem, but it isn't something you're likely to be able to get data on and therefore can't control. Okay, so in the paper, they do basically what we call robustness or falsification tests that can potentially help detect whether or not this common trends assumption holds. So sometimes you'll hear it, the assumption that these factors will change equally in both control and treated states, you'll hear that referred to as a common trends assumption because the assumption is that both of the two states, the outcome is in a common trend. So one thing that people will do is they'll look for whether or not there's a differential trend between treated and control states in observable factors. So for example, the drinking rate, as I said, is something that we can get data on, right? So what you could do is basically see, is it the case, or examine, is it the case that drinking rates are changing differently over time in treated states versus in control states? And the argument there would be, if there are these differential trends, then maybe you'll see them show up in the observable factors, the things you actually have data on, things like drinking rates. And if you don't see them appearing in those observable factors, so if you see that there is a common trend in drinking rates, then you might sort of infer or at least hope that for all of the unobservable factors, there is also a common trend. So there is not a differential trend for these other unobservable factors. And so that's it's at least suggested evidence that your research design might be correct in the sense that it seems like, at least based on the observable factors you have, your control group is a pretty good proxy for your treatment group, or a pretty good counterfactual. Another thing you can do is you can look for differential trends in the outcome. So this would be differential trends in the fatality rates prior to when the policy actually occurs. So this would be prior to 1987. And so I think we'll see, maybe not in this study, but certainly when we get to the cancer cluster study, you'll see sort of that evidence being presented. And then another thing that you can do is you can try to basically identify a control group in the treated states that was not treated. So the idea here is that not everybody, so when you roll out a policy in a given state, often it's the case that not everybody is actually affected by that policy. And so then if you have this sort of additional control group in your treated state, then you can see how that group does relative to the same, like equivalent people in the control state. And ideally, you should see basically the same change in the outcome for those two groups, because in the treated state, this group isn't actually being affected by the treatment. And so under our differences assumptions that the two states would have evolved similarly absent the treatment, you should actually see the same trends in the outcome for both of these groups. So I'm going to give you a much more concrete example of this in a second with the speed limit study here. Okay. So the speed limits, just to give you the background on what led to this policy change, the speed limits were lowered to 55 miles an hour everywhere in 1974. This was for energy conservation purposes because of the Arab oil embargo that increased gasoline prices significantly in the U.S. As an unintended consequence, it seemed like fatalities probably dropped. So you can just look at the time series in the fatality rate here. So this fatality rate for 100 million vehicle miles traveled.